To talk about. Thank you for inviting me. I'm over at the Queen Mary University here in London, where I teach in the and do research in the business school. It's great to know everyone here, and perhaps with some of you I may be in more contact later. I also happen to be a barrister focused on property, so I guess my research interest must be trying to figure out ways to use law to make some money. So the presentation I'd like to discuss is smart contracts, and I also have a book, and it's not fully driven by what I'm about to say, but one of the ideas, as Abel mentioned earlier, and so did Professor was it Mohammed, um, is that there's a lot of projects out there, and there's not a lot of looking for applications. And so I have a book on that. A lot of people are looking at it from engineering angles, but the ones to make money are what are good business ideas. The punchline I wanted to share with everyone and is what I believe is the fundamental function that smart contracts achieved, and that's driving market values for some of these projects like Ethereum. And I think that's the anonymous contract ability. Then I would argue from that the best applications of smart contracts would be towards that feature. But let me explain that a bit more. So first of all, we're in this thing about Web 3.0. Web 2.0, people say it's the one with the Facebook and social media, user-generated content. Now we have this Web 3.0, people have not quite defined it yet, but it seems to involve blockchain and decentralized control. I would say that it's probably something to do with privacy and anonymity in terms of online activities. We know that, for example, Bitcoin alone is good returns, good valuations. A lot of crypto assets and crypto firms, everybody in um, is somehow related. But what is the point to it? And is there do people understand what they're trying to solve? So I'm going to argue that the privacy aspect is going to be the key one, and that projects should consider that to be a central area, promising area using smart contracts. I mean, there's a lot of other applications. Obviously, I mean, tokenization of things is clearly, especially of real estate, as we earlier saw. Gavin's also a lawyer, so that's clearly a very applicable area, but it's not applicable in the same sense as smart contracts. And also, land registry, getting that onto the blockchain, like in Dubai. Clearly, those are clear applications, but not really of smart contracts. So what is smart contracts? What's the key feature of that? Because a lot of the problems we have is already solvable using normal contracts. I mean, to get onto the blockchain, we need something more that the blockchain can deliver, the normal contracting cannot. So what is that? So we can look at this first by the original Natoshi Sakamoto. If we look back at the first couple paragraphs, this is what it writes. So basically, it's trying to say that there's commerce on the internet. It's relying on these card payment processors, electronic payments. System works well enough for most transactions, but it still suffers from weaknesses of a trust-based model. What does that mean? So completely non-reversible transactions are not possible because we need somebody in the middle to mediate any disputes. And the cost of mediation, Satoshi thought, increases transaction costs and limiting the minimum practical transaction size and cutting off the possibility of small casual transactions, which is presumably what he wanted to do. And there is a broader cost in the loss of ability to make non-reversible payments for non-reversible services. Now, so in his mind, he has the idea that this trust is based on this middleman who needs to trust the middleman to resolve disputes. because they say that because of that, merchants must be weary of customers and get more information than they would otherwise need to process the transaction. A certain amount of fraud is unavoidable. These costs and payment uncertainties can be avoided in person with physical currency, but he saw that this kind of internet, it doesn't work. You need a middle person that's a trusted party. I mean, the more I think about uh, uh, this, the more I actually think, especially in 2008, I think Satoshi Nakamoto wanted to sort of, view dirty pictures online without having to give his credit card to buy them. The dirty pictures, dirty videos, whatever it is. I think that's what he somehow had in mind, because there are small transactions and they're irreversible services, and be able to pay it anonymously. Did he actually achieve that? Well, let's think about this. So he wanted to pay for small contracts over the internet. Now he wanted something without a dispute resolution mechanism. He didn't like the middleman, the Visas and the American Express, that you can have a chargeback in the banks where you can go complain if you have a dispute. So he was concerned about anonymity, and he believed that cutting out any dispute resolution mechanism would result in lower transaction costs. Um, uh, well, did he achieve that with Bitcoin? Well, let's think about this. So here's an anonymous payment. Now, Bitcoin at the time could do anonymous payments. In theory, it still can, but the exchanges now want know your customer and stuff. But if you buy Bitcoin off the street, you could in theory still get it anonymously. Now, let's say that A pays B, and that's irreversible. Now, how does this contract work? Now B needs to do something for A. Let's say transfer something back to A, like a JPEG pic, or some kind of password or some other kind of service. Now, what is there to force B to give A what A had paid for? Because A paying B in Bitcoin was irreversible, but there's nothing now to force B to deliver on the promise back to A if they had some kind of contract to buy some kind of service or product. So in fact, Bitcoin achieved only half of what Satoshi Nakamoto wanted. There was no anonymous contracting, so Bitcoin alone did not work. It's just a series of points, basically, that people can send to each other, and they found a way so that all points are legitimate. So there's no fake points going around. So there was no anonymous contracting. But the big deal with Ethereum and smart contracts is that, of course, we can pre-program it. So we can say something on the blockchain that basically goes, if A transfers this much Bitcoin to B, then B transfers this password to the file to A, or something of that nature. Let's say it transfers Ether to A, so another cryptocurrency back to A. Now this whole thing can be programmed on the blockchain so that it's a pre-program. So now, if provider A does it, B must transfer back to A something. Okay, so this kind of thing is what smart contracts allow. Now that can be done anonymously over the internet, and in fact, if one were to think about this, this is huge. Okay, so before, two people cannot transact anonymously over the internet at all. Well, why not? Well, exactly for the reason we just talked about. If one side did their part, there's nothing at all to get the other side from doing their part, their half of the deal. So if you think about it, over the internet, nobody could do anything without being able to do it. Because over the internet, if you're anonymous and cannot find each other, now why not? What do we do if somebody breaches a contract in real life? Well, Gavin, lawyers know we sue them. But suing people, you have to know who to sue. You cannot contract anonymously and expect to be able to sue them afterwards. So there's no enforcement mechanism. Okay, now, or dispute resolution mechanism. So you cannot really sue an anonymous counterparty for breach of a contract. Okay, so Ethereum, the smart contract, actually managed to do something that was previously not possible to do on the internet. And it's not just anonymous, but anonymity is a big part of it. I mean, if you wish to, there's also weak enforcement jurisdictions. I mean, if somebody in Mongolia wanted to do some kind of digital trade with somebody in the middle of the Congo, there's nothing that you can reliably enforce that contract, even if they did know each other. But if we could write this code that automatically enforces the consequence after one party does one thing, then they could conceivably come and do deals with each other. The very simple thing is online gambling. We flip a tail on the internet, heads you win, tails I lose, or whatever the opposite way. Heads you win, tails I win. Two people on the internet cannot even do that deal, okay, without a smart contract, anonymously, or if they're from different countries that don't have a shared enforcement mechanism. Okay. So this was in fact a huge step, and I think it's actually the big step. It's a one small step for the internet, so to speak, one giant step for whatever technology that now we have something. It doesn't work perfectly, but at least we now have this way for people to do transactions on the internet. And I think that's driving a lot of the valuation of Ethereum and some of these other projects that allow or are built for smart contracting. A little bit of legal analysis. Now, earlier, our keynote speaker, Professor Mehmet, didn't thought that a vending machine was not, you cannot contract with a vending machine. There's a famous case that every law student, I think, I might remember, but I forgot the name. And the legal principle is that, yes, you can contract with a machine. Boots, it's the checkout booth machine. But let's do some legal analysis. We're not actually contracting with a machine here. Is this a contract in the legal sense? Now, in the common law criteria, there's 4 criteria, which I won't bore everyone with, but basically 2 parties. We're dealing with 2 parties, one in Mongolia, one somewhere in the Congo. Okay, so they need to somehow agree. And if you write it down in code and they agreed on it, so they would have reached agreement. They need to pay each other stuff, so there's consideration. So A does pay B, and B sends something back to A. That fits. They need to intend for this to be binding, which they would do, and the terms need to be certain. In this case, if you pay me 1 Bitcoin, I transfer you, 10 Ether. That's a very certain term. So this actually in law, on the simple face of it, is a contract, not with a machine, but between A and B. Okay. So it does fit as a contract. Now, so what is the value of smart contracting now? Well, it's allowing for the automatic enforcement between anonymous parties. Our A and B can be anonymous people on the internet. Okay. And if you think about this, this was previously impossible because you can't find a counterparty again. And so you cannot enforce any contract after performance of half of it. And this is fundamental in commerce and law in every jurisdiction. The enforcement of the counter action on the other side of a contract. So this seems to be a very major step. And the key point is that it's anonymous parties. It's not just people who know each other. People who know each other, contracting is easy. Me and Gavin can go out and do a contract today. And if one party defaults, we sue each other in the county courts in London or wherever. So that's easy. Smart contract doesn't really do much more in that scenario. But if I want to go online and buy some kind of secret password or some kind of dirty picture, I pay my Bitcoin. I want to make sure I get that product. Well, if you write it down into a smart contract, I can be assured of that, and I can do that anonymously. Now, that was something that you cannot do really before. Now, this is an early day kind of thing. So a lot of the valuation and everything is somewhat speculative. And we can think a little, I'll call it analysis, but it's a sort of legal analysis rather than numerical. So how far can this go, and what are the applications of this? Now, there's limitations, obviously, of contracting with computer programs, but computer programs can be contracts. Because the first main thing is that human language, the way we write contracts, agreements, may not always be codable. You may not be able to express them. For example, you rent a car. One of the terms may very well be that this rental car shall not be used for commercial purposes. Now, how can you write that into code? Well, you cannot. So these kind of contracts are not contractable as a smart contract yet. You just cannot express it clearly enough in computer code. Now, smart contracts tend to need to cover all contingencies. So it needs to be what's called a complete contract. Because if you have a contingency that happens outside the contract doesn't know what to do with it. So it doesn't react. So the contract itself should cover as many eventualities as possible. But this is likely solvable with the adoption of some kind of standard terms, like in construction, you have standard contracts and so forth. And if people adopt them, you would just copy in a whole bunch of code that covers a bunch of contingencies, like returning money if something happens and so forth. I mean, that's possible, but right now that's limited, and people haven't figured that out how to deal with that. And also, the thing is that not all terms in a contract are equal, because when you write a contract, some conditions are more important than others in the legal sense and also in practical sense. But computer code is quite binary. If you breach one condition, that's a breach. We don't know the difference between leeway in a computer program. So that's a problem that needs to be addressed in some way. There's also the issue that not all contracts in society are enforced. If you contract to do crime, if you or in England for surrogacy, I mean, those are non-enforceable contracts, and they're overriding law. If you do some kind of contract that the law does overrides, then those contracts are not practically enforced. And ultimately, any contract may need the judgment of a person under all the circumstances, and that cannot be coded yet. Now, we do have AI, which might presumably be able to get closer to a human judgment, and that's going to be something to potentially look out for. There's more difficulties in renegotiation, so that's the whole point of the contract, and you can't find the opposite party. It's a bit tortuous. You can do it again, but it's a bit tortuous to do. It's just some difficulties. Now, the key real thing is, especially in relation to practical applications, is that this is really just software, and it only works for digital transactions. You can somehow try to link digital transactions to physical reality, but the reality is this is software. So people sometimes say, look, Bitcoin, right? It's comparable to gold. I mean, it's not true. It doesn't. It says, oh, it's because gold is so unwieldy and bulky, heavy, and therefore Bitcoin sort of solves that problem. Well, it does not. I mean, Bitcoin is software. Software does not in any way reduce the weight of gold or the bulkiness of gold. So it only sort of solves a problem by analogy, and that's not solving a problem. If you solve a problem by analogy, you do not solve the original problem. But so there's something here between software and reality. There's a limit to how much software can do. It needs to be limited to information stuff. So a lot of the thinking about somehow linking it to reality has this fundamental issue. If you have a problem with gold and you prefer Bitcoin, that's fine. But Bitcoin did not solve the weight and unwieldiness, the physical problem of gold. Gold remains heavy and bulky and hard to move around, and Bitcoin did nothing at all to solve that. So there's sometimes a solving problems by analogy versus solving the actual problem itself. So this goes into some of the applications such as land registry and stuff, and what you actually own and so on. I mean, for example, earlier we looked at the land, and the land is clearly something people look at, try to tokenize it and so forth. But I mean, you can tokenize the conceptual rights to land, but physical possession, for example, can never be tokenized. I mean, whoever is standing on the land with a baseball bat preventing other people from taking it, it's not a problem that can be solved by software. Okay, so is it always anonymous? Is anonymity the key thing? I argue that was the starting point and the driving value of a lot of these smart contracting uh, projects like Ethereum. But after some further thought, I mean, obviously it's got potential as well when existing enforcement mechanisms are weak or lengthy. So my example of somebody contracting somebody in Mongolia contracting with someone in the Congo, trying to find some kind of common jurisdiction for enforcement, it's pretty difficult. So they would have to try to use a smart contract. So that works too. They don't have to be anonymous, but I think the original driving value of all this is anonymity. Now, again, I say so what are the applications? And right now, just the tech itself needs to be relatively simple. So we get on to what are the possible and promising applications of this. Now, the best and obvious application is online gambling. Fantastic application. Aside from whether people can run it, but you know, it's a game of chance. Everything can be coded. Nobody runs, right? So as long as it's all coded up, so that's a very obvious application of smart contracts that can be done already. If we think a little bit more, here's my summary. So basically, the main economic value contribution I think of smart contracts is the ability to enforce contracts that previously cannot be enforced, either because we have anonymous parties or weak enforcement mechanisms. Now, this alone has huge economic value. We haven't really found the precise setting to use it on, and the world is still trying to find that application, as Abba was earlier mentioning. But as soon as it finds it, it's going to have good use. There are some feasible applications um, uh, surrounding digital assets. Notably around copyrights is potentially a promising area, and also some financial assets like our original bearer bonds. Whoever held the piece of paper was entitled to the interest payment. Those don't exist anymore, but those are the types of things that can be applied. But in any event, it seems to me that a good application of smart contracts should be involving something that to do with privacy and anonymity, because that is what this technology, so to speak, was designed to be able to do over normal contracting. In other settings, it is difficult for me to see what the benefit is of a smart contract versus a regular contract. So I think the number of good ideas focused on privacy has so far not been very clear or the subject of big focus, but I think it should be, because I think those would be the promising application areas of smart contracts. They look like legal contracts without the identifiable parties. So that's an extra thing we have with blockchain and smart contracts, and that's something we did not have before. Okay, so if anyone has good ideas, I'd love to hear them. And that's my email if anyone wishes to be in touch. That's my idea here. So I just close that.